Our learning goal for today is that I can simplify, add, subtract, and multiply and divide fractions. So just kind of introduce or think about what division means. If I take 4 divided by 2, that means to take 4, say these 4 dots right here that represent that. We're going to divide it into 2 groups. The question is how many is in each group? And there's 2, right? So 4 divided by 2 is 2. So the question is, what is 5 divided by 0? And some of you might remember that it doesn't work, that you can't, it's undefined, it doesn't exist. The reason why, right, is if I have 5 things, I can't divide them into 0 groups. It's not possible. So keep that in mind. That won't, there's not a lot of that in your assignment today. In fact, there's nothing to do with dividing by 0. But just in the future, as we talk about fractions, and we'll get into rational expressions, which are fractions that have x's in them, we have to be really careful that we don't have a 0 on the bottom of the fraction. Let's start then just talking about multiplication. This is the most straightforward, easy thing to do with fractions. By the way, right here it says, if b and d don't equal 0, it just says that because they're in the denominator. We just said that, right? You can't divide by 0 or have a 0 on the bottom of the fraction. So that's why that's included. But the rule is this, right? If I times a over b times c over d, I just go a times c and b times d. An example of that would be 3/4 times 2/7. Okay, I multiply them together. 3 times 2, 6. We'll actually write it out, show our work on that whole thing. We're going to go 3 times 2, 4 times 7, so I end up with 6 over 28. Okay. Look at this next one, division. Let's talk about how we do that really quick. So with division, right, all we do is if you're taking AB divided by CD, you rewrite it and we go AB times, and you take the CD and flip it over, so D over C. So it really ends up just being a multiplication problem. So you have to rewrite it, and then once it's rewritten, we're just going to end up multiplying. Some of you may remember back in elementary school, like a lot of teachers say, the copy dot flip. Right, your first one, the AB stays the same, just copy it down, change the division to multiplication, and then you take the reciprocal of C over D. So you get D over C. An example of that would be this. If I have 3/8 divided by 2/5. Okay, so as soon as we see division, we're not going to divide them directly. Instead, we're going to rewrite it as a multiplication problem. So that would become 3/8 times 5/2. Okay, so these are the same thing. They're equivalent or equal to each other. Okay, now I can just multiply straight across like we just talked about. So 3 times 5 and 8 times 2. Equivalent fractions. If I take a fraction, I'm going to, right, if this is a whole over here, if I take a half, that fraction right there would represent a half. We can take that same shape, and now I'm going to divide it again. So now they're divided into 4. So that is now 2/4. But if you look at it, it's actually the exact same shape as we already had, right? The same amount of area shaded in. So what that means is 1/2 and 2/4 are the same thing. You could even go again. We could divide it like that. So now I've got 1, 2, 3, 4, 5, 6, 7, 8. So now I've got 8/16, right? 1/2, 2/4, 8/16. They are equivalent fractions is what we call them. So if you look up here, I can take a fraction a over b. If I times it by the same number on the top and the bottom, then I still have an equivalent fraction. The fraction has the same value. That's going to be helpful for us too, going the opposite ways. We can simplify fractions. If I have a times c and b times c, I can reduce those c's or simplify them and just have a over b. So an example of that is this. If I have 8/12, and I want to simplify that down, what I'm going to look for is what's a factor they have in common. So you could do 2. 2 goes into both of them as a factor of both. You could also do 4. 4 is a factor of both. So if I rewrite it as being 4 times 2, that would be 8. And rewrite 12 as being 4 times 3. What happens is this. I'm going to show all the steps here. You can break those apart. 4 over 4 times 2 over 3. And the 4 over 4 is just 1. So now I have 1 times 2/3, which is really just comes out to be 2/3. So 8/12 and 2/3 are equivalent fractions. When you take out all the common factors and we say it's simplified all the way or reduced completely. So normally I'm always going to ask you that if you have a fraction, we're going to try to simplify or reduce it as far as we possibly can. Here's another example. If you had, excuse me, 3/9. So again, look for a common factor. Well, 3 goes into 3 and 3 goes into 9. So I can think of this as being 3 times 1 and 3 times 3. And again, what happens is the 3 over 3 simplifies down to be 1, so it goes away because you're multiplying by 1. So my answer is 1/3. So simplifying fractions, make sure you always, if you have an answer, it's a fraction, should always be as simplified as far as we can go. Check for common factors. Okay, where it gets a little bit trickier is when you're adding and subtracting fractions. When you go to add or subtract fractions, you have to have a common denominator. So what we mean by that, the denominator is down here, b, right? I should have done that right at the beginning, right? Just a quick reminder, all right, my a over b. The top number is called the numerator, and the bottom is called the denominator. I think you've heard that before, but just a quick reminder. So to add or subtract, we have to have a common denominator. Those have to be the same. If they are, notice how it stays the same after I add. All I do is just add the top. Okay, over here, right, we got a common denominator. You subtract them, so a minus c, but again, the denominator stays the same. So the trickiest part, adding and subtracting is actually pretty simple. The trickiest part, the part we struggle with the most usually, is finding a common denominator between the two. So here's an example. If I have a 3/4 plus 5/4, okay, first thing you check for is, do we have a common denominator? And we do, it's 4. The second thing is, be careful not to add them together. That means my answer is out of 4. Okay, now I add up my numerators. 3 plus 5 is 8. So we end up with 8/4. Now we ought to simplify that. This one actually, 4 goes into 8 evenly, so we could just divide those. That would actually just come out to be 2. With subtraction, here's one. I've got 3/7 minus 1/7, so let's be a 7 there. Okay, I've got a common denominator. The denominator stays the same. I just subtract the numbers on top. So 3 minus 1, which is 2. So that's easy enough, right? That's not too bad. But where it gets trickier is if you don't have a common denominator. And this is where you have to be careful. So if I look at that first, let's say I had this. I had 3/4 plus 1/8. I want to find out what that's equal to. You cannot add those two together as long as they're in that form, as long as they have different denominators. So my job is going to be to find the least common denominator. And what that means is you're finding the smallest number that 4 and 8 both go into. So what I'll do a lot is just start with the bigger number 8. You know, what are the multiples of 8? You got 8, 16, 24. Well, what's the smallest one of those multiples that 4 also goes into? Well, 4 goes into 8 twice. So 8 goes into 8 and 4 goes into 8. That is your least common denominator. So what I have to do now is I have to change these fractions. I have to change them to an equivalent fraction that has the same denominator. So what I mean by that is I want them both to have an 8. Well, this one's already there. It's got an 8. This one doesn't. So I'm going to times that 4 by 2. If I do that, I can do that as long as I also times the top by 2. This is what we were talking about a minute ago, is that they'll be equivalent fractions. So I'll end up with 3 times 2 is 6, 4 times 2 is 8. So I get 6/8 plus 1/8. Okay, now I've got a common denominator. Now I can just add it together. Again, be careful to leave the 8 the same. I just add the numerators, so it comes out to be 7/8. Let's do one more. Let's do a subtraction one, just because, again, these are the tricky ones. If I have 2/3 minus 1/4. Okay, so to subtract, recognize first there's not a common denominator. So next step is to find it. So if I take the multiples of 4, right, I've got 4, 8, 12, and we're trying to find one that 3 goes into. Well, 3 doesn't go into 4, 3 doesn't go into 8, but 3 does go into 12. So 12 is my least common denominator. So I'm going to make them both 12. I'm going to times this one by 4 to get 12. That means I have to times that one by 4 also, so I end up with 8/12. This one I've got to times by 3 to get 12, so you got to times the top by 3. So I end up with 3/12. Okay, we've got our common denominator, so I just go 8 minus 3, 5. Okay, so 5/12 is what it comes out to. Hey, so really big things. Just know multiplication, you just multiply straight across. Division, you have to rewrite it as a multiplication problem first, then multiply straight across. With addition and subtraction, you've got to have a common denominator. It has to. So on your assignment, work down through those. Make sure with all your answers that they're reduced. So if they have common factors, make sure you take that out. But this is just good practice. You've all seen this before. This is a practice just to make sure we remember some of our fraction stuff. Later on, we're going to go get into rational functions, which is fractions with variables. In order to simplify those or add or subtract those, we use these same principles. So reviewing this is good because it helps us work with fractions, but it also helps us later on when we get to those rational numbers. Thanks, guys.